This section is about subset of R, which is necessary to uh, do essentially all the programming necessary for Data 101. We call this subset R101. This is no more than 20 instructions, really 10 basic ones, and they allow you to do pretty much everything we do in this class, from hypothesis testing to finding and verifying patterns in data, Bayesian reasoning, and building prediction models. So let's move on. We have three categories of R instructions. One that is very basic one-liners, allowing us to compute the mean of numerical values, standard deviation, uh, come up with the columns of a data frame, summary of data, etc. These are just one-line instructions. Number two, four instructions for basic plots. Data visualization is very important in data science, and we will talk mostly in this class. We'll use scatter plot, bar plot, box plot, and mosaic plot. So we'll discuss basic instructions, again, one function for each of those plots with a bunch of parameters which allow you to introduce colors and captions and basically beautify these plots. Number three, perhaps the core instructions which allow a very simple data analysis. These are subset, supply, table, aggregate, which is a version of supply, and finally merge. In fact, three of those instructions we call the magic trio, subset, supply, and table, allow for 90% of data analytics, data analysis tasks. Library functions for some basic tests such as chi-square test, the permutation test, as well as recursive partitioning, decision trees, building basic prediction models using, for example, linear regression, performing cross-validation, etc. So if you count them, there is like 5 here, and in total, it's probably going to be 15. These are just very, very small kind of footnote instructions, so to speak, for recursive partitioning. So let's start with data frames, however. Data frame is a very basic data structure in R, and it's used as a container for any data set which we're going to upload to RStudio. So once you have RStudio, you can download any data set using one of the RStudio functions, and once you have it, you use the following instruction: read.csv. That's one of the basic functions, a read CSV file, which takes the data set which was uploaded to RStudio with, remember, with already mentioned check of consistency of directories. So RStudio has to be the same directory as the data set which you upload, and df is a data frame variable which gets initialized to that data set. This is first instruction in every program, every snippet of data which we're gonna use in this textbook. So any snippet of code, any executable code will start with this instruction. So read.csv is the beginning of every single program. For example, this is a screenshot of one of the snippets from active textbook, and what it shows uploading a data set from the cloud. Data set could be either on your laptop or could be on the cloud. In this particular case, there is this Moodle data set which is on GitHub account of one of my TAs, and DF and Moodle is data frame variable for this data set. Then we show how this data set looks like on the right hand side of the RStudio console, and we can see that it has several columns related to major, grade, score, etc. So it's essentially a table, and data frame is necessary in order to do anything, any programming in R. You need to have a data frame to hold this data set. So that specific snippet, which we're gonna review later in our practice voice recording, you will see what you can do with these snippets. I mean, the snippets are extremely useful learning tool. So let's talk about a basic core magic trio first, right? So subsetting rows. So we already saw how the full data frame looks like. Now, in order to be able to do anything useful, we need to perform subset operations on the data frame by taking a subset of columns and subset of rows. So as always, the first one is the Moody data frame, read.csv, and this is a URL which contains a Moody 2022 CSV data set. Next, suppose we want to do a subset of rows which describe a specific value of specific attribute. So for example, here, Moody underscore psychology data frame variable contains a subset of Moody data frame with major equal to psychology. Notice a very important feature of this function subset, right? So what you need to do is you need to give the name of the data frame, and you need to give a condition. It could be any combination, any Boolean combination, and or not, of basic conditions of the form attribute equal to value. So in this particular case, major equal to psychology, always in quotes, right? Psychology as the value of categorical variable. So I'll remind you about this when we proceed further on. nrow is the function, one of the basic functions, which very quickly allows you to compute the number of rows of a given data frame. And you can, by computing a number of rows of the psychology data frame and of the Moody data frame, we can see that it is indeed a subset of the entire set. The second number is going to be much smaller than the first number because we have multiple majors in this data frame. We can also subset columns. So subsetting columns is again starting with read.csv instruction, and here's how we do data frame columns. So here are the oh, sorry, this is even not columns yet, but basic subsets of the data frame, not only major equal to psychology, but major not equal to psychology. Also, we can subset based on the numerical attribute. So in this particular case, it's a subset of the score attribute, right? And next, we just proceed with a combination of two attributes. So these are this is an AND. We can also do an OR, which is the pipeline connector. Here, rows and columns. So how do we do a subset of columns? Well, subset of columns we use using the subset function. Subset function has this ability to also select a subset of columns. Here is the keyword select, which is used inside of the function subset, and if it's a minus, it means we are deleting the column this particular case, column 1. C stands for a vector concatenation. So it could be C1, it could be C1, comma 2, comma 3, as in the vector section of the active textbook. We'll review it later in the practice session. So minus means remove the column, plus means just keep, so in other words, if we drop minus, we can only identify columns which we want to keep. So by default, the remaining columns are going to be removed. So if select was equal to C1, comma 2, comma 3, we would only keep the first 3 columns. And again, we can see number of columns, just like number of rows of the new data frame, which we just calculated here. Subframing. So subset of data frame we can obtain using a subset function, or we can do something called subframing, which does not require any function, but requires square brackets. So for example, in this particular case, I believe we already did it on one of the first slides here. So for example, the subset of all tuples, rows of the Moody data frame with a score at least 80 is computed the following way. Square brackets, the attribute name, always with a $sign, and in this particular case, because if it's a numerical, more than 50. So here we get all the rows with at least a score of 50. There are some important points here. Here, of course, we can build it into arbitrary Boolean condition. In this particular case, a conjunction and disjunction. So disjunction is denoted in this way, and conjunction above here. Common errors. It's very important to pay attention in subframing to having that comma here. Without this comma, we will flag an error. It will flag an error unless data frame has just one column. If it has more than one column, you need a comma here. You also remember, again, just like in the subset function, that if you have a categorical variable, you need to use quotes for the values of the categorical variable. Why do we need subsetting? Subsetting is absolutely necessary in data exploration. That's a section in active textbook which discusses it at more detail. Why do we need? What is data exploration? First of all, data exploration is uncovering unusual patterns in data, identifying disproportional outcomes, comparative analysis. So finding anything interesting in the data set, something which is specific to a specific subset, something which shows or indicates a pattern in data. This allows also a special visualization and summary statistics to be demonstrated. So essentially, if you make a presentation based on a data set, this is what you're going to be using. You will be using something called data exploratory analysis or exploratory data analysis, rather, EDA. That's what the acronym which stands for data exploration says. Okay. All right. So we've covered subsetting. So just to summarize, we can subset rows, we can subset columns, we can use subset function, we can also use subframing. So important when we go into our discussion, question answering session, it's important to remember the following thing about subset. Right, subsetting can be done with one function or with a subframing feature of R. What is important is we can make arbitrary Boolean combinations of conditions in the subset operation. It's important also that categorical values are always in quotes. Finally, it is also important that when we use subframing, we use a comma inside the square brackets. Don't confuse square brackets in subframing with regular brackets in the function subset. Regular brackets are always a part of a function. Square brackets are part of the so-called vector notation in R, in the language R, and are used for subframing. So don't confuse these two types of brackets. In particular, when you write subset function, always use regular brackets, don't use square brackets. So table is very useful in finding distributions of data, and it's often used as an operation preceding a plot, a bar plot in particular. So for instance, right, let's make a table for grades of students and counts of students for each grade. So how many students get each of the grades? So the table does exactly that. What you need to do is you need to take a function table, one of the magic trio, table of Moody $grade. So this is the column grade of the data frame Moody, and table will tell us for different grades A, B, C, D, and F how many students represent each grade in this data frame. We can also calculate joint distribution, two-dimensional distribution of grades and major. In other words, for each grade and for each major, how many students get each grade and each major. This is very important. You can see here, table can have two arguments, not just one. With two arguments, it creates two-dimensional distribution. Again, it's a very important instruction which is used in visualization using so-called mosaic plot, which we will talk about later in the next section. Tapply. Tapply is a function which deals with numerical and categorical variables. Here is our data frame again, and we calculate distribution of mean scores for different grades. How do we do this? We use the function tapply. It has three arguments: score, grade, and mean. So what it does, it calculates the mean of the numerical variable, which is the first variable, first argument in the tapply function, depending on the grade. So that mean score depends on each of the grades. And we get similarly to what table does, where it is a frequency or a number of items. In this particular case is a numerical function. It's a mean plotted later in the form of a bar plot again as a function of the grade. Again, when we go over practice part of this section, we will show you the snippets in active textbook. We can also take subsets, right? And we can calculate distributions based on subset. For example, we may only look at students who are juniors. This is a subset using subframe notation, seniority equal to junior. Notice double equality here for equal sign, and calculate for this subset different grades, different means of the score attribute for just juniors. So how do juniors do for different grades? What scores, what mean scores they obtain? String operations. Yeah, well, this is a bit of an addition. We didn't include them into the core operations, but they're very useful functions. I'll show you when we go over the code snippets. This family of functions is a very powerful function called grep, Unix function, in fact, Linux function. We can calculate, we can test, given a string, input string, whether it contains a capital letter, contains a numerical value, or contains a punctuation sign. And all of this is basically the same function, just different parameters. That's all. So let's go to basic queries. Because we already have enough. We already know enough to to do some basic, very basic data, exploratory data analysis. Let's take another data frame. This data frame describes a hypothetical party. It's a party data frame with music, the day of the week, DJ name, attendance, and rating. So these are parties representing, different music like techno, hip hop, rock, different DJs, different numbers of attendance and rating. This is a URL which is section 24 of active textbook, in which we generate different coding tasks for different queries, and you can practice your ability to write simple queries. You can also see what is the correct code. I encourage everybody to go to section 24 and practice, and first practice and only then look at the correct code, because nothing is better than hands-on practice of coding. Reading code does not give you much. For example, this is an example of the query which we're going to generate. What's the smallest rating of a techno party? So how it is done, you can see minimum, which is the minimal value of the numerical values. So that applies to rating. Rating is numerical. I believe it's from 0 to 5. And we only look at the subset, look at the subframing construct here of the subset of the techno music entries in the party data frame. Here is, instead of minimum, is a mean rating of the techno parties. We can change techno to rock or to hip hop, and we can see and compare the difference between ratings. Are they higher or lower? Here is the attendance of highly rated parties. So we calculate a mean value of attendance for parties which are rated above 4. Again, quite complex logical function computed with just one line. That's the beauty of R. R allows you to do a rather complex operations with just one line. So remember what I mentioned earlier. By no means we're learning the full language R. In particular, we avoid for, while, ifs, typical constructs of a full programming language. And by the way, if you use GPT, which is allowed, don't use those constructs, right? Because we didn't cover them. And that simply means you run GPT and you copy the output from the GPT without understanding what it does. Only limit yourself to these one-liners, which we list here in the textbook in section 2.6, and we listed them here on one of the first slides. All right. So try 10 queries from the coding roulette, section 24 of active textbook. That's the URL. So looking for hidden patterns in data through simple queries in R. Well, that's the objective. That's why we learn all of this, because we want to discover something interesting about data. So there are different cases here, like we'll see for plots as well. Numerical versus numerical relationship, correlations. So this type of pattern involves correlations between two different numerical variables. For example, for Moody data set, it could be correlation between score uh, and attendance. If such an attribute is added for a party data set, could be a relationship between rating and attendance. So is this true that parties which are rated higher are attended more often or less often? So we can discover those relationships. We can also look at the relationship which depends on a different subset. For example, for techno music, maybe rating, maybe higher rated parties are attended more, but for jazz, the higher rated parties are actually attended less because it's more sophisticated music, for example. Categorical versus categorical relationship. We take two categorical variables and we look at patterns. For example, we may discover that psychology majors have a higher likelihood of passing a class with at least a C grade compared to computer science major. That can be calculated using basically relationships between two categorical variables. Very important knowledge about how different majors are graded. Numerical versus categorical relationships, interaction between numerical and categorical variables. For example, one can analyze relationship between students' score and their final grade. Usually, right? I mean, the higher the grade, the higher the score, but maybe the cutoff points will depend on the major or on seniority. And we would like to know the nature of this relationship. So using queries, which we just described, you can calculate those relationships. So for instance, in section 3.9 of active textbook, we calculate the differences between majors by using tapply. So we look at the mean score on different majors, and we can form a hypothesis for later hypothesis testing, which majors have the highest score and which have the lowest score in the class. We can also see a relationship between variables. For example, does higher GPA matter? What does it mean? Again, initializing data frame. And the question is, does higher GPA get you a better grade? How to test it? Again, one-liner. Okay, you write the apply function, and depending on Moody GPA attribute, you look at what is the mean of the GPA for different grades. Is this the case that the higher the grade, the higher the mean GPA? So that's what this function is going to calculate. We can also do it for a subset, like only for psychology majors. So there is a lot of information we can get using just these very simple instructions. Finally, merge. Merge is important when you deal with multiple data frames and you would like to combine information from multiple data frames into one data frame. For instance, right, we may have hypothetically one of our data sets which we in fact use is about movies. Movies where we store genre, content type, rating, PG, PG-13, R, and a country where the movie was produced. And now we may want, as we can see in our ABOLR tool, which I'm going to show, we would like to see is there any relationship based on continents on which countries are located. Well, for that we need another data frame, continents, which describe which country is on what continent. So we upload another data set and we form another data frame using this read.csv and data frame based on continents, country and continent, basically two attributes. And having them together, we can merge movies and continents by a country. So country is present in both data frames, in movies and in continents, and we can form them by joining, this is a term used in databases, by a country. So we take a country from a movie data set, and we look at the continent, corresponding continent to this country, and we include these attributes in the new data set, new data frame, which we called merge. So now merge has one extra attribute, continent, which comes from a different data frame. So that's what merging is for. And these are basically all instructions we're going to be using aside from library functions in our exploratory data analysis. In the practice part of this class, we will review snippets from Active Textbook Section 3.